Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kindly refers to the question. Given the function, we have the function fx and also the domain. Is continuous at x is equals to 1. Find the value a and hence determine the limit when x approaching a for the function fx. So in my suggestion, I would like to illustrate the situation in the real number line. So here we have the real number line. So focus on the function. The discussion is on the value 1. X less than 1. We have the function x plus 1. X greater and equals to 1, where we have the x squared minus x minus a over, we have x minus a. So, focus on the question. They said continuous at x is equals to 1. So, in order to find the value a, limit when x approaching 1 from the left is the same with limit when x approaching 1 from the right. For the function, x plus 1 on the left and x squared minus x minus a over x minus a. Kindly substitute the value 1 and we will have 2 on the left equals to, we have 1 minus 1 which is equals to 0. So here we have negative a over 1 minus a. Kindly cross multiply the situation and we will have 2 minus 2a equals to negative a. So finally, rearrange, we have 2 equals to a. Rewrite, a is equals to 2. Hence, determine limits when x approaching a. So in here, the a limit when x approaching a is equals to 2. For the function fx. So refers to the real number line, here we have the 2. So meaning that x squared minus x minus 2 over x minus 2. So if we substitute the value, and we will have the situation 4 minus 2 minus 2, which is equals to 0 over 0, where we have the indeterminate form. The suggested strategy would be, first, multiply by the conjugate, followed by the factorization, and the third one is long division. So for this question, my suggestion would be factorization. So limit when x approaching 2. So if we factorize the situation, and we have x minus 2, x plus 1 over x minus 2. Notice that we have the common terms. So we can simplify limit when x approaching 2, then for the function x plus 1. And the value of y is approaching 3. Next, we have the question B. Evaluate the limits when x approaching the positive infinity for the given function. So first what we have to do is to substitute the value, and we notice that we have infinity for the numerator and also infinity for the denominator, and we have the situation indeterminate form. The suggested strategy will be dividing the numerator and the denominator for the highest power of x for the denominator. So notice that we have the denominator, the highest power will be the x. So kindly factor out the x. So limit when x approaching positive infinity, we have the cube root. Factor out the x, so here we have x bracket, we have 2 plus with the 5 over x over, factor out the x, and we have 3 minus 4 over x. Continue, limit when x approaching positive infinity, we have the cube root, 2 plus with 5 over x over 3 minus 4 over x. If we substitute the situation, for example, 5 over infinity, and we will have 0. 4 over infinity, and we will have 0 as well. So, we have the cube root 2 over 3.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.